So rational functions. Here's the steps about how to graph the rational functions. So I just make it simple for you. Step 1 and 2, we have two options. Here's the function they're going to give you in the example. You're going to write down here, and if it's not factored, you have to factor the top and the bottom. We will see that on example. So the first thing, you're going to write down the rational function and the factored form. Step 2, from this part, you're going to find the y-intercept. From the original function, you're going to find the y-intercept. How? By let x equal 0. So you will get point from here, point or 2 points. From this part, you're going to find the x-intercept by the factored form, because this one is easier. You don't have to factor it one more time because it's already factored. So you're just going to plug in y equals 0, and then you're going to find the x-intercept. Step 3 is how to find the horizontal asymptote. First of all, let's see what's the meaning of horizontal asymptote. The horizontal asymptote, because we graph in a rational function, so we have horizontal asymptote. So when you have these coordinates, the x and the y, this is x, here is y. Again, we graph in a rational function. So we have to find horizontal asymptote and vertical asymptote. The horizontal asymptote we will find by using these steps, I'm going to show you, is going to be a horizontal line like this. This is a horizontal asymptote. Maybe it's going to be here, maybe it's going to be on the x coordinate, maybe it's going to be here. It depends about when we found the horizontal asymptote, how much is going to be the number. Maybe it's going to be like this. This is horizontal asymptote. The function on the horizontal asymptote, maybe it's not going to cross this line. The horizontal asymptote maybe sometimes cross the horizontal line. It depends about certain condition. Sometimes it's not across the horizontal line, like the function is going to be here. The function is going to be here, or it's going to be here, like this. I was going to be here like this. So you see, the function never across the line. So you see, this function never cross the horizontal line. That's why it's horizontal asymptote. But on certain condition, the function is going to be across the horizontal asymptote. So the horizontal asymptote is a horizontal dashed line. The function is not going to cross this line. Just in certain condition, if you take another math class, you will see what's this condition when the horizontal asymptote across the dashed line. Here is the first thing, horizontal. How are we going to find the horizontal asymptote? Here is the 3 types to find the horizontal asymptote. It depends about the power or the degree on the top part or on the bottom part. So for example, let's do this example. Before also going, so rational function, like if we have f of x equal 3x squared plus 2x minus 2 over 4x squared cube plus 6x. This is a rational function. Why? Because there's denominator and denominator here. So this is a rational function. Now, our step is to find the horizontal asymptote. Horizontal asymptote, I'm going to say just horizontal asymptote HA. That's mean horizontal asymptote. How are we going to find the horizontal asymptote? By using one of these conditions. Let's start with the first one. This is the rational function, how it looks like. Top part and the bottom part. It's like a rational number, but now we have a function on the top and a function on the bottom. That's why we call it a rational function. So now, the first condition, if the degree on the top less than the degree on the bottom. So let's check this example. The degree here on the top, which is the highest exponent, 2. The degree on the bottom, which is the highest exponent, is 3. Now 2 less than 3. That means it satisfies this condition, the first condition here. The degree on the top is less than the bottom. The degree on the top less than the bottom. So we're just going to say the horizontal asymptote y, because the horizontal asymptote goes with the y coordinate. We have to graph it on the y coordinate. If you see the example here, the horizontal asymptote, we're going to graph it on the y coordinate. It's a horizontal line, like this. So the horizontal asymptote on this function is going to be y equals 0. This is how to find the first condition, the horizontal asymptote. Let's check the second condition. So the first condition, the horizontal asymptote, when the degree on the top less than the degree on the bottom. So the horizontal asymptote y equals 0. The second condition, if the degree on the top equal to the bottom. That means we have equal degree. For example, if we have f of x equal 3x to the power 4 minus 2x over 4x to the power 4 minus 5x plus 2. Now I need to find the horizontal asymptote on this one. On this example, the degree on the top n equal 4. The degree on the bottom n equal 4. You see the highest exponent 4, the highest exponent on the bottom also 4. So 4 equal 4. What's that mean? That means we're going to work with the second condition, which is this one. If the degree on the top equal the degree on the bottom. So now the horizontal asymptote is going to be y equal the coefficient on the top over the coefficient on the bottom. The coefficient on the top, which is the number here, be careful here with the second condition. The condition on the top, the coefficient on the top, which is the number with the highest exponent, over the coefficient on the bottom, which is the number with the highest exponent. So my horizontal asymptote here is going to be y equal 3 over 4. This is the second condition. Y equal 3 over 4. The third condition, if the degree on the top greater than the bottom, you're just going to say there is no horizontal asymptote. We have another asymptote, which is called the slant asymptote. We're not going to do that in this course. Next course, you will get what's the meaning of the slant asymptote. So I need you to focus about the horizontal asymptote. If the degree on the top less than the bottom, that means the horizontal asymptote y equals 0. If the degree on the top equal to the bottom, that means horizontal asymptote equal the coefficient on the top over the coefficient on the bottom. If the degree on the top is greater than the bottom, you're just going to say there is no horizontal asymptote. We have one more asymptote, which is the vertical asymptote. And how are we going to find the vertical asymptote? We're just going to set up the denominator equal to 0 and solve it to find the vertical asymptote. Let's do an example about that, how to find the vertical asymptote. Because we're going to do these steps when we're trying to graph the rational function. Vertical asymptote, which is a vertical horizontal, a vertical line, vertical dashed line. Horizontal asymptote is going to be horizontal dashed line. So if we have the rational function 3x squared minus 2x plus 4 over x minus 6. To find the vertical asymptote, we're just going to take the denominator here and equal it to 0. So x minus 6 equal to 0. Then we're going to solve this one. I'm going to add 6 to the both sides. Cancel these. So x is going to be equal 6. That means there's a vertical asymptote. This is the vertical asymptote. Vertical asymptote x equals 6. So when you graph it, you're going to graph the coordinate 1, 2, 3, 4, 5, 6. There's a vertical dashed line on this number. You see, this is the vertical asymptote, vertical dashed line here, vertical asymptote when x equals 6. That means the function is never going to cross this dashed line. So on this side, maybe it's going to be like this, maybe it's going to be like this, like this, like this. The function never crossed this dashed line. That's why we call it vertical asymptote. It's a vertical dashed line. How to find it? We're just going to take the bottom part equal to 0 and solve it to find the vertical dashed line or the vertical asymptote. The last step is extra points, because we're going to need extra points to complete a graph. So again, we're going to use these steps to graph a rational function, and on the same time, sometimes on the examples of the test, they're going to ask you just to find the horizontal asymptote or just to find the vertical asymptote. So you have to know how to find these vertical and horizontal asymptote. So let's do an example about rational function and how to graph it. Let's choose one of these examples here. Here's one. I'm gonna put this one inside in case we need it. So here's the example. So we have, it's telling you a graph f of x equal 4x over 2x plus 9 and x plus 1. So here's the example, how to graph it. We will see that. We're going to do exactly the same process. Step 1, you see what I'm going to do? I'm just going to put the line in the middle. So step 1, I'm going to write down the function here and the factored form here. So here is the function, which is 4x over 2x plus 9 and x plus 1. And if you check this one, it's already factored. So because you see the bottom part and the top part, it's only one term. The bottom part is already factored, so I'm going to write down exactly the same thing. But some examples, you need to factor one of these parts, the top and the bottom. But on this one, you have already the function written in the factored form. Over 2x plus 9 and x plus 1. Now, next step 2, on this side, if you remember, on this side, we need to find the y-intercept. How? By let x equal 0. So here, step 2, I'm going to find the y-intercept. How? By let x equal to the 0. So I'm going to let x equal 0 here, here, and here. Let's see how much it's going to be. That means f of x, which is the same thing, y, equal 4 times 0 over 2 times 0 plus 9, 0 plus 1, and it's going to be 0 over 9 times 1, 0 divided by any number is going to be 0. That's mean the y, that when x equals 0, the y equals 0. That's mean y-intercept is x equals 0, y equals 0. This is the first point. The x-intercept, sorry, the y-intercept. Now, with this form, with this side, we're going to find the x-intercept. How? By let y equals 0. We're going to let now y equals 0. So how I'm going to let y equals 0? That means this part, because f of x is the same thing, the y. So I'm going to plug in 0 on this side, equal 4x over 2x plus 9, x plus 1. Now I need to find the x-intercept. So check what I'm going to do. It's easier to solve this one. So check what I'm going to do. This side is 0. So I'm going to write down the 0 over 1. Just 1. Now multiply 4x by this one. 4x times 1 is going to be 4x equal. This side times 0. Any number times 0 is going to be 0. Multiply 4x times 1 is going to be 4x. This side times 0 is going to be 0. Now I need to solve this one. Divide both sides. Let's do another step. 4x equals 0. Divide both sides by 4. So x is going to be 0. Divide by 4 is going to be 0. So the x-intercept, x equals 0, and the y equals 0. So we have exactly the same point. This is the x-intercept. So 0, 0 is the y-intercept, and 0, 0 is the x-intercept. So we're done from step 1, which is write down, step 1, write down the original fraction, write down in factored form, if you can factor it or no. But if you see this one's already written in the factored form. Find the y-intercept from this side by let x equal 0. Y equal, you're going to plug in 0, 0, 0. So it's going to be 0 over 9 times 1. 0 divided by any number is going to be 0. So the result is going to be 0. That means the y-intercept, x equals 0 and the y equals 0. Find the x-intercept from the other side by plugging y equals 0. This side is the y. So 0 equal 4x over this one. I'm going to write down the 0 over 1. So 0 over 1. Now I'm going to multiply 4x times 1 is going to be 4x. 0 times any number is going to be 0. Now divide any number by 4. Divide both sides by 4. Cancel these. So x is going to be equal 0. That means the x-intercept is going to be also the same point, 0, 0. Next step, step 3, we're going to find the horizontal asymptote. So step 3 is to find the horizontal asymptote. How are we going to find the horizontal asymptote? We have to use exactly the same option, which is we have 3 conditions, 1, 2, 3. And it depends about these 3 conditions about the degree of the polynomial of the rational function. So let's write down the function here, which is f of x equal 4x divided by 2x plus 9 and x plus 1. Now check on the top part. The degree on the top part, which is the highest exponent, is 1. So n equal 1. That means the degree equal 1. The highest exponent here is 1. Now check on the bottom part. The degree on the bottom part, I have 1 here and I have 1 here. 1 plus 1 is going to be 2. That means the degree on the bottom part equal 2. 1 plus 1 is going to be 2. The degree here, because this is written in the factored form. So when you FOIL this part, is going to be 2x squared. When you FOIL this part, let's do it on the side. 2x times x is going to be 2x squared. 2x times 1 is going to be plus 2x. 9 times x is going to be plus 9x. 9 times 1 is going to be plus 9. Combine the like terms, it's going to be 2x squared plus 11x plus 9. So the highest exponent is 2. The highest exponent is 2. Now, 1 less than 2. That means if the degree on the top, less than the bottom, so that means the horizontal asymptote y equals 0. So I'm just going to write down the horizontal asymptote y equals 0. I'm done from step 3, is to find the horizontal asymptote. Step 4, now we need to find the vertical asymptote. The vertical asymptote, we're just going to take the bottom part. Here's the function, f of x equal 4x. I'm writing down this again, but you don't have to write down the function again. To find the vertical asymptote, we're just going to take the bottom part and equal to the 0. So I'm going to say 2x plus 9, x plus 1 equal to the 0. We need to solve this one by using zero factor property. So I'm going to say 2x plus 9 equal to the 0 and solve this part. Minus 9 from both sides. So it's going to be 2x equal negative 9. Now divide both sides by 2. So x is going to be equal negative 9 over 2. That means x equal 4.5. 9 over 2. This is the first vertical asymptote. On the other side, x plus 1 equal 0, minus 1 from both sides. So x is going to be equal to negative 1. This is the second vertical asymptote. Now you see, I have two vertical asymptotes. I'm going to graph it. I have one horizontal asymptote, also I'm going to graph it, and 2 points, the y-intercept and the x-intercept. On this example, we have exactly the same point, but maybe you're gonna get different points. It depends about the example. We're gonna use all this information to graph the rational function. One more step is to find the extra points. I'm gonna show you when we start graphing how to choose the extra points. The x-intercept and the y-intercept at the same point. X-intercept and y-intercept, which is the same point 0, 0. And we have the horizontal asymptote y equals 0. And we have the vertical asymptote. We have two vertical asymptotes. The first one is y equal negative 9 over 2. And sorry, x, not y. And x equal the vertical asymptote with the x equal negative 1. I can simplify this part because it's hard to graph a function. So I'm going to say x equal negative 9 divided by 2 is negative 4.5. It's easier to graph. So this is all information I have. I'm going to use it to graph the rational function. So let's graph these points. The first thing, they say the x-intercept and the y-intercept exactly the same point. Let's graph this point, which is the 0, 0. Then the horizontal asymptote, which is horizontal dashed line. It says when y equals 0. That means when y equals 0, this is the x coordinate. Y equal 1 is going to be goes one step up. Y equal negative 1, one step down. y equal 5, 1, 2, 3, 4, 5. Y equal -3 is going to be 1, 2, 3. That means this is the horizontal because horizontal dashed line. But when it says y equals 0, that means it's going to be exactly here on the x coordinate. So it's going to be horizontal dashed line on the x coordinate here. Exactly on the x coordinates. That's why sometimes you can't tell there is a horizontal asymptote when you see the graph, but you have to know it from the fraction. So the horizontal asymptote when y equals 0. This is the first thing. Horizontal asymptote, y equals 0. Now, what about the vertical asymptote? Vertical asymptote is going to be vertical dashed line. I'm just gonna fix these points so we can. Okay, now the first vertical asymptote when x equals -4.5. 1, 2, 3, 4. 4.5 is going to be here. So it's going to be a vertical dashed line on this one. This is the vertical asymptote, which is the function never going to cross this dashed line. So vertical dashed line here. This is the first vertical asymptote when x equals -4.5. This is the vertical asymptote, the first vertical asymptote. The second vertical asymptote when x equals -1. So x equals -1 is going to be here. Let's add x space here. This is x equals -4.5. And here x equals -1 is going to be here. So check, we have two vertical asymptotes and one horizontal asymptote. This is the second horizontal vertical asymptote when x equals -1. Check, this is only the information we have. We have x-intercept and y-intercept at exactly the same point. We have one horizontal asymptote when y equals 0. We have two vertical asymptotes. Now, how are we going to grab the rational fraction? That's why in this case, we need extra points. Extra points, check. I told you the horizontal aspect, the graph of the function, of the rational function, never going to cross these two vertical asymptotes. So now I need to figure out how it looks like the graph on this side, because I already know that the function never going to cross this vertical line, vertical dashed line, the vertical asymptote. So I need to figure out how the graph looks like here, and I need to find how the graph looks like between these two points, between these two lines, the vertical asymptotes, and I need to find how the graph looks like on this side. So let's start picking a point. We're gonna pick 2 points here. We're gonna pick 2 points here is going to be enough. 3 points here is going to be enough because I need to figure out the graph, how it looks like on this part. And 2 points here is going to be enough. But don't forget, you already have this point, which is the x-intercept and the y-intercept. So now let's start picking the point on this side. Let's start from this side. I'm going to take this is -6, -7, -8. 1, 2, 3, 4, 5, 6, 7. So I'm going to take -6 and -7. Let's do it. One more, -8. Because this is half. This is the point. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's take 2 points, -6 and -8. So I'm going to do a small table here for the points, the extra points, x and y. So if I took -6, how are we going to find the y? You're going to plug in the y on the original function, this one. on this one. You're going to plug in the x here to find the y. Plug in the x here, plug in the x here and here to find how much is going to be the y. So the y is going to be negative 1.6. And I'm going to take negative 8, the other point. The y is going to be 0.12. So this is the first part. I took 2 points here. When x is negative 6, this is negative 6. 1, 2, 3, 4, 5, 6. This is negative 6. The y is going to be negative 1.6. That means it's going to be down. This is going to be almost 1.6 here. Then negative 8 is going to be negative 1.2. It's almost near the 0. This is negative 6, 7, 8 is going to be here. So here's the 2 points. So now, if you need to graph this part, I have 2 points. So check how I'm going to graph it. Like this, then the graph goes down to this point. If you take another point, if you take negative 6, negative 5 is going to be here. So that if you take negative 5, so the graph goes down, and I already know the graph never crossed this line. That means the graph goes down like this. Because my graph never going to cross the line, the dashed line, the vertical asymptote. So you see, this is the graph of this part. We're going to take 2 points, plug in these 2 points on the function, the original function, you will get the y, then the graph, these 2 points is going to be the graph for this part. You see, this part, the function never crossed this dashed line. Now let's graph, take 2 points between these 2 dashed lines. In fact, I need more than 2 points, because maybe the graph like this, maybe the graph like this, or like this goes down, or it's going to be like this. So I have to make sure I have negative 4, negative 3, and negative 2. So I'm going to, let's take these 2. If I took 1, 1.5 here, so I'm going to take negative 1.5, plug in negative 1.5 in the function, the result is going to be 2. The y is going to be 2. Take negative 2, negative 1, negative 2 here, and the function is going to be, negative is going to be 1.6, and take negative 4, the y coordinate is going to be 5.3. So check here on this part, all these 3 conditions, all these y coordinates is going to be on the top. So let's graph these points. Negative 1.5, this is 1, this is 1.5, is going to be 2. That means going to be here. This is the first point. Negative 1.5 is going to be 2. Negative 2, which is this point, is going to be 1.6. This is 1. 1.6 is going to be here. So the function is going to, the point is going to be here, because 1.6 between 1 and 2. Negative 4 is going to be 5.3. This is negative 4. So it's going to be 1, 2, 3, 4, 5. It's going to be 5.3, almost here. So check, I have 3 points. I already know the graph is never going to cross these 2 lines. That means the graph goes down, from this side goes up, and the graph goes down like this, and goes up again, and never going to cross this line, so it goes like this. This is the first point, this is the second point, and the graph like this. So the graph goes up from both these sides. I already know it's not going to cross this dashed line because this is a vertical asymptote, and the function never going to cross the vertical asymptote because the function is undefined when x equal -1, and the function is undefined when x equal -4.5. So that means it's never going to cross this dashed line. Now we have just one more part which is this part. So I'm going to take 2 points from here. You can take 2 and 4, it doesn't matter. So let's take 2, 1, 2, and we can take the 4. So when you plug in 2 in the function, it's going to be 0.18. When you plug in 4, it's going to be when you plug in 2, it's going to be 0.12. You're going to plug in 2 in the main function and find the result, how much is going to be the y. When you plug in 4, it's going to be 0.18. Now let's check these 2 points. This is the 2, 1, 2 is going to be 0.1. That means 1.2 is going to be almost here. This is the 1.2 is going to be here, a little bit up. 2, 3, 4, when it's 4 is going to be 1.8, is going to be almost here. So you see, never going to cross this dash line. So on this side, the function is going to be like this, goes down like this to the x-intercept and the y-intercept, because this is a point apart from the graph, goes down and never cross the vertical dash line, so it goes down to the end, to the infinity here. Never cross this dash line. So you see, the rational function, it depends about vertical asymptote and the horizontal asymptote. And I told you sometimes your function going to cross, because here's the vertical asymptote, is going to cross the vertical asymptote, but never going to cross the it's going to be cross the horizontal asymptote here at this point, because here's the horizontal asymptote, but never going to cross the vertical asymptote, because our function is never going to be defined when x equal -1 and when x equal -4.5. That means the function is undefined at these 2 points. That's why we can't let the function cross the vertical asymptote here, and never let the function cross the vertical asymptote here, also here and here. This is the graph of the rational function. Let's do another example about how to graph rational function. So graph this rational function. So I'm going to do, you see, on this part, this example, if you see the rational function here is not in factored form. So first of all, here on the first step, I'm going to write down the function of x equal x squared plus 6x minus 7 over x squared minus x minus 20. And I'm going to write down the factored form on this side. So how I'm going to write down the factored form? So I have to use the AC method here, and I have to use the AC method here. It's just exactly the AC method. So the result here is going to be, that's why you have to know how to use the AC method. It's going to be here, x plus 7, x minus 1, and here is going to be x minus 5, x plus 4. It's the AC method. Let's do one of these to refresh your memory about the AC method. So let's use the AC method on this one, x squared minus 6x plus 6x minus 7. The AC method is 1 times 7. It's going to be 7. I'm going to use 1, 7, or 2. There's no 2, just one option, 1, 7. So 1, 7, I'm going to say -1 plus 7. That means it's going to be x squared minus 1x plus 7x minus 7. Now we have 4 terms. We're going to group the first 2 terms and the last 2 terms. What's the common here? The common here is the x. And the leftover is going to be x minus 1, because x squared divided by x is going to be x. X divided by x is going to be the 1. plus, what's the common here is the 7. 7x divided by 7 is going to be just x. Negative 7 divided by 7 is going to be minus 1. So this one's similar to this one. So it's going to be x minus 1 and x plus 7. So this is the AC method. I'm going to write down the result here. You're going to do the same thing with the bottom part. You're going to write down the result here. So this is the original. This is the fraction, and this is the factor, the same fraction, but in factored form. Next step here, we're going to find the y-intercept. So let's find the y-intercept here. Step 2. Is to find y-intercept. How to find the y-intercept? You're gonna let x equal 0. So I'm gonna let x equal 0 here, 0, negative 7, 0, 0, and negative 20. So that means f to the 0, which is the y, is going to be 0 squared plus 6 times 0 minus 7 over 0 squared minus 0 minus 20. This is 0, this is 0, negative 7, and this is 0, this is 0, so it's going to be negative 7 over negative 20. That means y is going to be equal 7 over 20. 7 over 20, which is equal 0.35. Because I can't graph 7 over 20, so 0.35. That means the point x is 0 and the y equal 0.35, which is really small point near the 0. So this is the y-intercept. I have only now the first point. Now let's find the x-intercept, step 2 on this side. X-intercept. How? By let y equal 0. Again, where is the y here? The y here is the same thing f of x. So it's going to be 0 equal x plus 7, x minus 1 over x minus 5 and x plus 4. Again, what are you going to do here? Change the 0 to 0 over 1, because if you write down 0 over 1, it's not going to change anything. 0 divided by 1 is going to be 0. Multiply this side by 1. So it's going to be x plus 7, x minus 1 equal. Multiply 0 by this side is going to be 0. So the x-intercept always is going to be the top part. Always the x-intercept is going to be the top part. Now, I'm going to use the zero factor property here. So x plus 7 is going to be 0, minus 7 from both sides. So x is going to be equal to negative 7. So the first x-intercept on this one, x equal negative 7 and y equals 0. Let's do the same thing on the other side. X minus 1 equals 0. You're going to add 1 for both sides. Cancel these. So x is going to be equal 1. So I'm going to grab the second x-intercept, which is 1 and 0. So I have now 3 points, 1 y-intercept and 2 x-intercepts. We're done from the first and second steps. Step 3 is to find the horizontal asymptote. How are we going to find the horizontal asymptote? Let's go back here. That's why the horizontal asymptote is easier to find from this one, not from the factored form. The vertical asymptote is easier to find it from the vertical asymptote, from the factored form. Keep this notes in your mind, because this is already factored. So I'm just going to take the bottom part and equal to 0 to find the vertical asymptote. But this one, just we need the degree. Check the degree on the top and the degree on the bottom. So I'm going to write down the function again. F of x equal x squared plus 6x minus 7 over x squared minus x minus 20. The highest exponent on the top is 2. The highest exponent on the bottom is also 2. So in this condition, let's go back to the first notes. We have, if the degree on the top equal the degree on the bottom, so we have to use this option. Horizontal asymptote is going to be the coefficient on the top over the coefficient on the bottom. That means the horizontal asymptote is going to be y equal an over bn. What's the meaning of an? That means the coefficient with the highest exponents, with the n on the top, which is 1. Here is the coefficient 1. And the coefficient here is also 1. That means y is going to be 1 over 1. So the horizontal asymptote y equal 1. This is the horizontal asymptote. Now, the vertical asymptote, step 4, to find the vertical asymptote, we're just going to set the denominator. You see, the horizontal asymptote, always we're going to take the original form, because we're going to take the highest exponent, and it's not factor. But the vertical asymptote, it's easier to find it from the factored form. So I'm going to take the bottom part here. I'm just going to say x plus minus 5 and x plus 4 equal to 0. Then I'm going to use the 0 factor property to find the solution. So x minus 5 is going to be equal 0. I'm going to add 5. So x is going to be equal 5. This is the first vertical asymptote, x equal 5. On the other side, x plus 4 is going to be equal 0. I'm going to minus 4 from both sides. So x is going to be equal negative 4. This is the second vertical asymptote. So we have 2 vertical asymptote, we have 1 horizontal asymptote, and we have 2 x-intercept and 1 y-intercept. We can use this information to graph the rational function. Also, we need extra points, and we will see that when we start graphing the function by using these points. So let's start graphing the rational function. The first thing, I'm going to write down all the information here. So here is the x-intercept, these 2 points, the y-intercept 0 and 0.35, and the horizontal asymptote, the vertical. So always I'm going to start. So here is the x-intercept, negative 7, 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. So this is the first x-intercept, negative 7 and 0. And the second x-intercept is 1, 0. So here is 1, 0, 2 x-intercept. The y-intercept is 0, 0.35, which is going to be here, this than 0. This than the half. So I'm going to do the y-intercept here, because it's less than half. Vertical asymptote, horizontal asymptote y equal 1. So see, we're going to graph the horizontal asymptote when y equal 1. So it's going to be horizontal dash line here on y equal 1. So this is the horizontal asymptote when y equal 1. This is the horizontal asymptote y equal 1. Now let's graph the vertical asymptote. The first one is x equal 5. 1, 2, 1, 2, 3, 4, 5. So this is the first vertical asymptote. when x equal 5 and x equal -1, sorry, x equal -4 is the second vertical asymptote. 1, 2, 3, 4 is going to be here. So this is the second vertical asymptote. X equal -4. Now all these information, we got it. There is no more information we need to add. We have, this is the two vertical x-intercept. Here is the y-intercept. Two vertical asymptote, one horizontal asymptote. Now, how are we going to grab the rational function? We need to use the extra point. Let's do a small table here on the side with x, y. So I'm going to choose, this is the positive side. That means I have 3 parts. This is the first part here with this vertical asymptote. The second part between these two lines, between these two vertical asymptote, and the third one is going to be on this side. So I need 2 points here. This is 5, 6, 7. So let's add one more point. Five, 6, 7, 8. And here's the horizontal asymptote, y equal 1. So I'm going to choose 2 points here because this is the horizontal asymptote. I'm going to choose the 6 and 8. Let's plug in the 6 and the 8 in our function to get the y coordinate. You're going to plug in 6 and 8 here. Here with the original function to get the y coordinate. So the result is going to be 6.5. That's mean when it's 6, it's going to be 1, 2, 3, 4, 5, 6. 6.5 is going to be almost here. When it's 6. When it's 8, it's going to be 2.9. Like almost 3. So 2.9 when it's 8, 1, 2, 3 is going to be less than 3. So it's going to be almost here. So you see we have 2 points. That means my graph is going to be from this side goes up because it's going to be going up but never cross the vertical asymptote, and it goes down, and like this, and never across this line. So on this side, the graph looked like this. And here's the vertical asymptote, keep going up. So the graph never going to cross the vertical asymptote. Between these 2 points, I have one x-intercept and I have the y-intercept. But I need to figure out the graph goes up from this side or goes down from this side. What about this side? The graph goes up or down. So I'm going to pick a point here and I'm going to pick a point here. Let's choose a point here, 1, 2, 3, 4. I'm going to choose the 4 here. And I'm going to choose negative 1, 2, 3, negative 3 here. And let's see how it's going to be the graph. When it's 4, the y coordinate is going to be negative 4.1. So when it's 4 on this side, it's going to be 1, 2, 3, 4.1 is going to be almost here. That's mean the graph like this never cross the vertical asymptote, and the graph going up to the x-intercept, then keep going up to the other side to the y-intercept. Then let's check how much is going to be with the 3. The graph goes down or goes up. So when it's negative 3, you're going to plug in negative 3 in the original function, you will get 2. That means the graph goes up. This is 1, this is 2. -3, and 2 is going to be here. That means the graph goes up to this point and keep going up here. So here's the graph for the part between these, the part of the function between these two vertical lines. The third part here, after the vertical line when x equal -4, we have one x-intercept. I just need one more point here. This is -7. I need -6 or -6 or 5. So I'm going to take -6 and check the graph how it looks like. So the third part, I'm just going to choose one point when it's -6. So when it's -6, it's going to be -0.3. So here's -6, -4, 5, 6 is going to be almost here. That's mean the graph, see between these 2 points, because this is x-intercept, and the graph on this side goes down, never across the vertical asymptote, and from this side, the graph goes like this. And also never across the horizontal asymptote from this side. So this is the graph from the first part, this is the graph from the second part, this is the graph for the third part. How to find the rational function from the graph, or sometimes they give you information about the rational function and you have to write down the rational function. The first thing, you have to locate the x-intercept. First thing, you have to locate the x-intercept and y-intercept. We're going to use the y-intercept a lot. Second step is find the horizontal asymptote. Step 3, find the vertical asymptote, and you're going to use this rule. Always the function is going to be x-intercept on the top over vertical asymptote on the bottom. And you're going to use the horizontal asymptote to check the power of the degree on the top and the degree on the bottom. So let's do an example about that and how we're going to use this information to find the rational function. So now find the function x-intercept 3 and 4, y-intercept 12, vertical asymptote 1, horizontal asymptote 1. So let's check how we're gonna, the first thing, locate x-intercept. So I'm gonna say x-intercept which is 3 and 4. That's mean x equal 3 and x equal 4. That's mean here it's going to be x minus 3. I'm going to put this in parentheses. X equal 4, that means x minus 4. So you see, this is the x-intercept is going to be on the top. Here, I'm going to find I'm going to use the vertical asymptote. Vertical asymptote, it says x equal 1. That means x minus 1. So this is the vertical asymptote. So I'm going to write down the function. Horizontal asymptote, it says y equal 1. So I'm going to write down, use this rule here. alpha for the x, it says x-intercept on the top. Where's the x-intercept? These two parentheses on the top. So I'm going to say x minus 3 and x minus 4 on the top. Vertical asymptote here. So here's the vertical asymptote, which is x minus 1. Now, here's the important thing we have to do. You see, we're going to use a lot x-intercept, vertical asymptote, and horizontal asymptote. Here's the x-intercept, x equal 3 and x equal 4. I'm just going to move 3 to the other side, so it's going to be x minus 3 and x minus 4. Vertical asymptote, x equal 1, that means x minus 1 with a parenthesis. Using this rule, so it's going to be x-intercept on the top and the vertical asymptote on the bottom. So this is the rational function, but we need to check. So let's go back. When horizontal asymptote y equal 1, what's that mean? Let's go back to the first page. So the first page, it says, to find the horizontal asymptote, we have 3 options. The first option, if the exponents on the top of the degree on the top less than the degree on the bottom, so horizontal asymptote y equals 0. If the degree on the top equals the degree on the bottom, that means the horizontal asymptote is going to be a number. That means you have to find y equal a number here. If the degree on the top or the exponents on the top greater than the exponents on the bottom, there is no horizontal asymptote because we have another asymptote, the slant asymptote. We're not going to cover this one on this course. So now, that means I have y equal 1. That means the exponents of the degree on the top is supposed to be equal to the degree on the bottom part. That means the degree on the top equal the degree on the bottom. So let's check the degree on the top. The degree on the top, even if you FOIL this one, x times x is going to be x squared. X times 4 is going to be negative 4x. Negative 3 times x, negative 3x. Negative 3 times negative 4 plus 12. So it's going to be x squared minus 7x plus 12. The degree on the top is squared. So we need to make the degree on the top equal the degree on the bottom. Squared. So what I'm going to do here, I'm just going to add 2 here. Because the degree on the top is squared. Now the degree on the bottom is squared. So that means this is the solution. Now my rational function is going to be x minus 3, x minus 4 over x minus 1 squared, because the degree on the top is going to be equal to the degree on the bottom. So that's it for this example. So now here's another example. We need to find the rational function by using these information. You need to write down the rational function. By using this information. I have x-intercept 1 and negative 4, vertical asymptote x equals 0 and x equals negative 1, and the horizontal asymptote y equal 1. How are we going to write down? Let's start with the x-intercept. So the first step, x-intercept x equal 1, that means x minus 1. And x equal negative 4, that means x plus 4. So these are the two x-intercepts. Here I'm going to use the vertical asymptote. The vertical asymptote, x equals 0. Be careful here. X equals 0, it doesn't mean that means x minus 0. It's going to be just x. X equals 0 is going to be just x by itself, so be careful on this one. X minus 5, x equal negative 5, is going to be x plus 5 with parentheses. So we're done from these horizontal asymptote, and I'm going to write down the function here. Horizontal asymptote, it says y equal 1. That means the degree on the top is equal to the degree on the bottom. The degree on the top is supposed to be equal to the degree to the bottom part. So now I'm going to say f of x equal. Always the x-intercept on the top. Here is the x-intercept, these two parentheses, x minus 1, x plus 4. The vertical asymptote is going to be on the bottom, so I'm going to write down x and x plus 5. Now let's check the degree on the top equal to the degree on the bottom. X times x is going to be x squared. That means the degree on the top, x squared, that means the degree here is 2. X times x is going to be x squared. Now that means the degree equal 2. So the degree on the top equal the degree on the bottom. So the solution is going to be this one. We're not going to add anything. This is going to be the right solution. So the next example, when we have a graph, you're not going to get any information. You have to take the information from the graph, which is the first thing we need, the x-intercept, the vertical asymptote, and the horizontal asymptote. So let's see the x-intercept, which is the graph intersect with the x coordinate at this point and at this point. 1, 2, 3, 4, 5, 6. So I'm going to write down x-intercept the point is 0, 0, and the point is -6 and 0. These are two x-intercept. That means from this one, x equal 0, and from this one, x equal -6. I'm done. I found the two x-intercepts from the graph. Let's use it. So x-intercept, remember when I told you when x equals 0, that means just x. X equal -6 is going to be x plus 6. Now we finished x-intercept. The second step is the vertical asymptote. Check where is the vertical asymptote. The vertical dashed line when x equal -3, 1, 2, 3. So vertical asymptote when x equal -3, that means x plus 3. We're done from the vertical asymptote. The third step is the horizontal asymptote. We have a horizontal dashed line when y equal 1. You see the horizontal dashed line, y equal 1? So that means when y equal a number, that means the degree on the top equal the degree on the bottom. This is the second condition. So now we need to write down the rational function. We're going to write down f of x equal always the x-intercept on the top over vertical asymptote on the bottom. So f of x is going to be equal. X-intercept, I have two x-intercepts, x and x plus 6 over the vertical asymptote, which is x plus 3. Now, I have to make the degree on the top equal to the degree on the bottom. The degree on the top, x times x is x squared. That means the degree is 2. But I have here only x. So what I'm going to do to make the degree on the top equal to the degree on the bottom, I'm just going to add 2 here. Now, the degree on the top equal the degree on the bottom. That's it. That means this is the solution. This is the function for this graph.